Chapter 5, Section 5.2, Linear Models, Investigation 5. 1. In a chemistry experiment, a liquid is heated and its temperature observed. The graph shows the temperature of the liquid in degrees Celsius, T minutes after the experiment starts, up to the end of the experiment. Describe how the temperature changes throughout the experiment. How much does T change for every 1 minute increase in T? Small t, the time. This is the rate of change of T with respect to time. Let's try to understand the graph here. We've got on the y-axis the temperature, and as usual, time is normally on the x-axis, and it is here. There's the time there. It's a straight line. Now the question was, describe how the temperature changes throughout the experiment. How much does T change for every 1 minute increase in the time? Well, if we go to 1, and we go up to here, and we just get the slope of that line, we get the rise over run. What's the change in this distance here on the y-axis, the temperature axis, for the time of 1 minute? Okay, and that's called the rate of change. The rate of change is actually the slope. It's this distance change divided by this distance change. And we've seen that before. It's just the gradient. It's y2 minus y1 over x2 minus x1 will give us the slope. And we want it there. That'll give us for every 1 minute. Now that'll be the same if we use this minute. If we use between 2 and 3, we'd have exactly the same distances as we have back here for between 0 and 1. Similarly, if we use between 4 and 5. This is because it's a straight line graph. It's a linear graph. 2. In another experiment, a liquid is being cooled and its temperature observed. The graph shows the temperature of the liquid in degrees Celsius, T minutes after the experiment starts, up to the end of the experiment. Describe how the temperature changes throughout the experiment. What is the rate of change of T with respect to time? Let's understand the graph again. This is the temperature here in Celsius, and this is the time here in minutes. Now this time the slope is negative. And that's not surprising because the liquid's being cooled, so it starts out very warm and then it gets cooler and cooler as time passes by. Now the question is, what's the rate of change of T with respect to time? Well, it's the slope. Again, it's the slope. We've seen negative slopes before. It's just the gradient formula, y2 minus y1 divided by x2 minus x1. So in this case, remember, it's the slope, the gradient still is the rise over run, but here it's not a rise, it's a drop. That's still the run. This is why we get it negative, because the change in the y-axis is negative, but in the x-axis it's still positive. So the rate of change will be negative because the rate of change is the change in y divided by the change in x. And if the change in y is negative, it's a drop, then the gradient will be negative. 3. Consider these linear functions. So we've got 3 functions and they said that they're linear. Now why are they linear? Well, we've seen this before. It's of the form mx plus b, and we already know that's linear. Also, x is to the 1 power. It's not squared, it's not cubed, it's not 1 over x, it's not x to the minus 2, it's just x. So that's linear. Same here. And when you've got something like this 3, that says the function value is 3. So that's a horizontal line at 3. Remember, this is the y-axis. Okay, that's the value at the y-axis. So if you've got this function here equals 3, that means it's a horizontal line that passes through y equals 3. For each function, what is the rate of change of the dependent variable with respect to the independent variable? B. When the independent variable increases, what is the behavior of the dependent variable? Now complete the table. We have to do this for each function. Now, what is the dependent variable and what is the independent variable? Just always remember that independent variable is the x value. That's the initial variable that you choose. It's normally on the right-hand side of the equation. It's the x. Once you choose that one, the left-hand side's decided. If I choose an x is 1, that's got to be 5. And GL 3. Okay, so that was wrong, right? If it's a 1, that would be 3, okay? If we choose 1 here, that's the independent variable. That's going to be minus 3 plus 2. That would be minus 1. So this equals minus 1 when x equals 1. And here, it's always going to be y equals 3. It's going to be the horizontal line. It doesn't matter for what x value. This function's always going to be 3. Okay, so it says for each function. So these three functions here are here, here, and here. The first thing is we have to graph the functions. Well, you could use your GDC, but these are simple enough that you should be able to remember. If this is mx plus b, well, the b is where it crosses the y-axis, because that's where x equals 0. Okay, so we know that crosses the y-axis at 1, and we know that it's got a positive slope because this point, this one, the one that becomes the coefficient of x is m. So that's m, and this doesn't have an m. Okay, it's got no slope, it's a horizontal line, we said, right? So here, remember m is defined as a change in y over the change in x. So 2, you should look at that as 2 over 1. It's got a change of 2 vertical for every change of 1 horizontally, because it's 2 over 1. It's a change in y over the change in x. Okay, so the way that would look is it would cut through at 1 on the y-axis. It has a positive slope, so it goes that way. It has a steep slope. It's steeper than 45 degrees because for every 2 it moves up, it moves across only 1. For 45 degrees, it'd have to move up 2 and across 2. That would be just a coefficient of 1 in front. It'd be 2 over 2, right? That's 1. But in this case, it's steeper than 45 degrees. This one here, it passes through 2 because when x equals 0, the function equals 2. It's a negative slope. That means, and again, visualize this as minus 3 over 1. So that means it drops 3 for every 1 it moves to the right on the x-axis. So it's a negative slope, and it is quite steep, and it crosses the y-axis at positive 2. This one's a horizontal line that just goes straight across, and it has no slope. Now, we said the rate of change is just the gradient. So the rate of change of the dependent variable, that's the rate of change of the function with respect to the independent variable. So that's our change in y over the change in x. So the rate of change in here is 2. It goes up 2 for every 1 across, so it's 2 over 1. This one here, it drops 3. It's minus 3. So it drops by 3 for every 1 it moves to the right. And for this one, there's no rate of change. It's just flat. It's just our one horizontal line here. And this one, as the independent variable increases, the dependent variable, what happens? Well, as you increase the independent variable, the dependent variable also increases because it's got a positive slope. This one, as you increase, right, as you move to the right, the dependent variable decreases because it's got a negative gradient, negative slope. And this one is no slope. Okay, so as we independent variable increases, the dependent variable doesn't change at all because it's a horizontal line. 4, conceptual. How is the rate of change of the dependent variable represented on the graph and in the function? Well, the rate of change represented on the graph is either a positive slope or a negative slope. And in the function, m, the y equals mx plus b, the m is going to be positive number if it's a positive slope and negative if it's a negative slope. 5, conceptual. What does the gradient of a linear function represent? Well, it represents the rate of change of the function. 6, conceptual. When the rate of change is negative, what happens to the dependent variable as the independent variable increases? Well, if the rate of change is negative, the dependent variable is going to get less as the independent variable increases. So the dependent variable will decrease when the independent variable increases because it's got a negative slope. A linear model has the general form of the function equals mx plus c, where m and c are constants. The graph of a linear model is therefore a straight line. Recall that m is the gradient of the line and c is the y-intercept. Note that not all processes have a constant rate of change, but when they do, they can be modeled with a linear function. The rate of change of a function is the increase-decrease in the dependent variable for every unit by which the independent variable increases. An increasing linear function has a positive rate of change. A decreasing linear function has a negative rate of change.